Hey guys, this is Gradius, and this is a video for factoring trinomials, or also just factoring polynomials. So, what we're going to be doing today is we are going to factor trinomials. A trinomial now has three pieces. That's why it's a trinomial, not a binomial. It's also known as a polynomial. Polynomial can be for any amount. And we're going to do this by finding the factors of the constant and checking the sum. And I'm going to explain everything of what that means. So, we're going to factor problems that look like this: x squared plus bx plus c. So I'm going to have an x squared up front, I'm going to have x times something else, and then I'm going to have a constant in the end that has no x attached to it. Whenever we factor this, we should get it into a form that looks something like this. So I'm going to have two sets of parentheses, and within those parentheses I'm going to have x plus a number p, and then x plus a number q. So this q and p are going to be any number, and these x's will be x's. So x plus a number p times x plus a number q. And this also might be minus. This might be minus, and we'll talk more about that later on. But this factor form goes into two sets of parentheses like so, and it's always going to be x in the front plus or minus some number afterwards. Okay, and the conditions are that if I take p and q and I add these, so these p and q, if I take my last two numbers and I add them together, it needs to equal b, the middle number attached to the x. Okay, if I multiply p and q, it should equal c. So when I add them, it needs to equal this b, and when I multiply them, it needs to equal c. And we're going to go through an example of how to actually figure out what numbers do that. We're going to do about 4 examples in this video. So I have a trinomial here, or a polynomial, x squared plus 11x plus 18. So what I want to do in order to solve this, I'm going to find the factors of the constant. So here's my constant, 18, because there's no variable attached to it, so that's considered the constant. And I'm going to see if their sum equals b, because if we remember from this slide before, I know that I need to have two numbers. If I multiply them, it's going to equal this, and if I add those same two numbers together, it's going to equal this. So I need to figure out what two numbers can I multiply that's going to equal 18, and if I add them together, it's going to equal 11. So first I want to list all my factors of 18. Well, I know I can do 18 and 1. Those are factors because 18 times 1. I can do 9 and 2. I can do 6 and 3. Those are all the factors of 18. Combinations that I can multiply to make 18. So all these would work because if I multiply 18 times 1, I'll get 18. 9 times 2, I'll get 18. 6 times 3, I'll get 18. Now I've got to figure out which one of these sums equals 11. Well, 18 plus 1, 19. 9 plus 2, 11. 6 plus 3 is 9. So 9 plus 2 is 11. That's the sum of the factors of 18. That's the sum that equals 11. So what that means is that when I factored this out, I'm going to put 9 and 2 as my p and my q. So x plus 9, x plus q. It does not matter what order I did it. I could have done 2 and 9 here. It does not make a difference. Okay? And the way we can check our work is we can use FOIL. So first, outer, inner, last. We can use FOIL to figure out if this factored version equals this. So I have x squared, x times x, plus 2x. 9 times x is 9x. 9 times 2 is 18. X squared plus 11x plus 18. I get the same answer, so it works out. Okay, so we found the factors of our constant, and we figure out the sum of those factors to see which one's going to equal the b term in the middle. Let's do another one, but we're going to mix it up just a little bit here. And what we're going to do is we're going to factor this trinomial. But if we notice, this has a negative now. So now when I'm checking the sums, I want to make sure my sum is going to equal a negative 6 instead of a positive 6. So the first thing I need to do is find my factors of 8. So factors of 8, I have 8 and 1. I have 4 and 2. And I think that's it. So I have 8 and 1, 4 and 2. Well, if I add 8 plus 1, I'm going to get 9, a positive number. 4 plus 2 is going to give me a positive number. So, and if I know my sum has to equal negative. But what I also know is if I take a negative 8 times a negative 1, it's going to equal positive 8. If I add a negative 8 plus a negative 1, it's going to equal negative 9. So I have a negative sum here. So that's good because I need a negative 6. So same thing here. If I take negative 4 and negative 2, negative 4 plus negative 2 is negative 6. So negative 4 and negative 2 are still factors of positive 8. There's the bell. Whoops. So that means when I factor this out, I'm going to have x times something,
Oscar
x times something.
Pinedo, please come to the office. Oscar Pinedo, please come to the office.
Interruptions all over the place. Sorry, guys. So, and now I'm going to plug in my factors inside here, inside my parentheses. So I figured out that the two factors of 8 are negative 4 and negative 2, and their sum is negative 6, which is my middle number. So I'm going to have x minus 4, x minus 2. And that would be the factored version of this trinomial. And again, I can check by doing FOIL, x times x times negative 2 minus 2x. Negative 4 times x is negative 4x. Negative 4 times negative 2, positive 8. X squared minus 6x plus 8. It worked out. So I got another one, but a little bit different again. Now I have a positive b, but now my constant is negative. So I need to find factors of negative 15. And I need to find the sum of those factors. So 15, right away, we know we have 15 and 1. But if it's a negative 15, I might have one of these numbers has to be negative. So I could do negative 15 times 1. And I could have done it the other way. So I could also do positive 15 times negative 1. These are possible combinations. Okay. For 15, I could also do negative 5, positive 3, or negative 3, positive 5. Now I'm going to check their sums. If I have negative 15 plus 1, I have negative 14. This does not equal 2, so these are not my factors. 15 plus negative 1 is positive 14, not 2. It's not my factors. Negative 5 plus 3, the sum of those is negative 2. I need a positive 2. This is a negative 2, so that will not work. Positive 5, negative 3 is a positive 2, which is right here. So those are going to be my factors. So now I have x, I have a negative 3 here, and then x, and I have a positive 5. Okay. Again, it does not matter the order. So I could have also had x plus 5, x minus 3. This would have worked as well. Okay. And if I go back and do FOIL and I check it, it would double check to make sure that I had the correct answer, and it will equal this. Finally, we are going to have equations where we're going to have to factor in order to solve. So I have this equation right here. X squared plus 3x is equal to 18. Now I have this equal sign, so now it's an equation. Now I actually have to do some work here. A little bit more work than just factoring. So the first thing I want to do, though, when I'm solving polynomial equations, like we've done in the past video, what I want to do is I want to solve for 0. So I want to get one side equal to 0, so that way I can solve for x. So what I want to do is I'm just going to move this 18 over so I have a trinomial on one side. So I have x squared plus 3x minus 18. And all of that is equal to 0 because 18 minus 18 is 0. Now what I can do is I can factor it out, and then we can set both pieces equal to 0. So I need factors of 18. That's what I'm looking for here. And I know their sums have to equal 3. So factors of negative 18, So if I want a factor of negative 18, I could do 18 and 1, 18 and 1, but different negatives. I could do negative 18 times 1, 18 times negative 1. I could also do negative 9 times 2, 2 times negative 9. Extend this. I also have possibilities of negative 6 times 3, and then 3 times negative 6. Whoops, I did the same thing there. Huh. Let's erase that. Positive 6 times negative 3. So here's all my possible factor combinations. And I'm looking for a sum that's going to equal 3. So right away now, instead of just writing down all these sums, I know that's not going to equal 3. 18 minus 1 is not 3. Negative 9 and 2, there's a difference of 7. It's not going to work. Difference of 7, not going to work. So it has to be one of these two possibilities. So I know it has to equal positive 3. So negative 6 plus 3, that's going to be negative 3. 6 minus 3, positive 3. So these are my correct factors. So I have x plus 6, x minus 3. And all that is still equal to 0. So I have the product of two pieces that's equal to 0. So that means either one of these can be equal to 0. If I have 0 times whatever x minus 3 is over here, it's going to be 0. If I have x plus 6 times 0 over here, it's going to be 0. So this is, if you need a little bit more help on solving these equations, I do have another video if you haven't watched it yet. But I'm going to set each of these equations equal to 0 as we've done in the past. And I'll solve for x to get my possible solutions. So x can equal -6 or x can equal 3. Both of these will satisfy this equation if I plug them in. I could always plug them in to check, but it should work. Okay? And that's all I've got for you guys. So I hope this video helps. So just remember, when factoring, you guys, the biggest thing is that when we have our two factors is that we find the product, the factors of the constant. Okay, so we have to factor out our constant first, and then the sum of the factors have to equal b. So for example, as we did in this first problem, I needed to find factors of 18 because this is my constant, and then when the sum of those factors have to equal the b in the middle. Good luck, and let me know if you have any questions. Thank you for watching.